Mr. Minnick here, helping my students with strings worksheet number 2. In exercise 1, the substring method is being called on the string object variable message. So let's count off the positions in this string value. The T is in position 0, and the H is in position 1, and so on. So by counting correctly, the first parameter in the substring method is 3, which means start at position 3. We're starting at the M. And we go up to, but not including, the value in the second parameter. So position 8, if you count it out yourself, is the R. So that means we take the substring that starts with the M and goes up to, but not including, index position 8. So the variable word, which we're printing out, is mouse. And on this worksheet, because that's a string, I want you to show the double quotes around the string value mouse. In exercise 2, by the way, it is legal to set message declared as a string without setting it equal to something. That's very legal. And the substring here only has one parameter, which means you find position 20, which is this H in Hill, and you extract or you take the substring of all the remaining characters. So the answer is Hill. Again, we need to properly wrap it up in double quotes for this worksheet. Exercise 3, let's follow the order of operations and work from inside the parentheses out. We first must compute the length of message. When you're computing the length of a string value, you actually count the characters. You do not start at 0. You count the characters. So the J in Jack, that would be 1, that would be 2, that would be 3. If you count these up, I think it's 24. And the next step in the order of operations would be to take 24 minus 4. All of that simplifies to 20. But you're now in the parentheses of the substring method, and you've turned exercise 3 into a copy of exercise 2. So the answer to number 3 is the same substring, Hill. Number 4, this is legal syntax to take a string literal value and double quotes itself and call the substring method upon it. Let's start at the position 3, 0, 1, 2, 3. It's the second L, and because there's only one parameter there, we take everything from that point on, and that is the answer, low. Number 5, very interesting. If you look it up in the API or my lecture notes or anywhere else, or you test it out in a IDE like, say, JGrasp, number 5 tells you to go to position 5 of low. Well, let's count. 0, 1, 2, 3, 4. There is no character in position 5. Well, it's not an error, though. You are allowed to type in a value that's 1 greater than the position of the last letter. In fact, because the length of hello is 5, you are allowed to put the length of the string itself in there. So how does the answer get represented? In other words, what would print on the screen? Nothing would print. I want you to refer to that as the empty string. I should have said that up here in the directions. I probably will change that for future versions of the worksheet. But that's the right way to represent the empty string, also known as the null string. Double quotes right next to each other. Do not put a space in between. Do not do that. Okay, number 6. That would be illegal, and that gives you a string out of bounds error. And you're supposed to fully explain your error. So I'm not going to put the answer here in this video. I want people to listen to the video, but you should be writing down error and something like string index out of bounds. Because if you have any number 6 or greater, or any negative number, you would get that out of bounds error. You're just not allowed to do that. Only the length of the string itself could be used possibly as a parameter. Number 7. Now the string digits has these numbers which kind of throw you off, but note that the 0 is in position 1, the 2 is in position 1, and the 3 is in position 2, etc. So that 9 would be in position 8, and that 0 would be in position 9. Okay, POS. It's being declared as an integer variable, and because the method index of does return an int, there is no error here. So what does index of do? It finds this substring inside of this substring, this larger string. So the 6 is in position 5. So it's a 5 that's returned by index of, and a 5 gets plugged into the variable POS. So right here, you could think of that as 5, and we have to mathematically add it to whatever this turns out to be. Well, is there an A in digits? No, I don't see the lowercase letter a there. Well, if you look it up in my notes or in the API for the string class, -1 is what all of this simplifies to. I'm not going to write it in here on this worksheet. I want people to listen to the explanation. But 5 plus -1 simplifies to 4, and 4 is the answer that you get here. Please write that on, and we would not put double quotes around it because it's an int value. Do not put double quotes. I really don't want you to put all answers, double quotes around all answers here. I will probably get around to changing the directions here. Do not put double quotes around number 7. Number 8, I love sandwiches. Position 5 would be the S is in position 5 if you count off starting at 0. And because it's only one parameter, we're taking the whole remaining part of that string, sandwiches. But now we have to, order of operations here, we work from left to right with these dots. We now have to find the length of sandwiches. Well, count up the number of characters in sandwiches. Start counting the S at 1. Whatever that comes out to, that answer should not be surrounded in double quotes because it simplifies to an int. The length method returns an int. I'll let it up to you to count the number of letters in sandwiches as your answer to number 8. Moving on then to number 9. Here we have the string concatenation compound operator. So whatever name was has do tacked on to the end of it. Java will not put a space there. It just glues them together with string concatenation. So that ends up being the answer to number 9. But please write it over here. Number 10, we are going to word 1. Be careful and look at the notation here. Word 1, substring 1, 2. So position 1 is the E, and position 2 is the first L. The way substring works is you start at the E and you go up to, but not including, the letter in position 2. So it's just the single letter E that's being stored now into the left-hand side over here, word 1. So in other words, hello was just overwritten with the value E. It's currently stored in the variable word 1, E. And that has nothing to do with the final answer. Because the final answer, oh, it does. The final answer is, oh, I see. It's tricky. Okay, let's be careful here as we follow this code. Because strings are immutable, I'm going to have to erase all of this and start from scratch and clearly trace it step by step. Word 1 is equal to hello. So maybe you want to represent that with a little column of scratch work. Word 2 is equal to word 1. So in other words, word 2 has whatever word 1 stored into it. But because strings are immutable, word 2 is its own copy. They don't share the same chunk, the same word, not really. It is storing the memory address, but we'll soon see that this line of code will overwrite word 1 with the letter E that we previously explained how the E is extracted as a substring. Word 2 is not being overwritten with that letter E. Word 2, when we system out print here, is still hello. So the answer is hello, with double quotes around it and a capital H. I'm not going to write the answer in because I want people to listen to this video. Number 11, name 1, substring 0, 8. We start at position 0 of name 1. We go up to, but not including, the 8. I think the 8 is the, well, I'm going to count to be sure. 0, 1, 2, 3, 4, 5, 6, 7, 8. The 8 is that blank space. So Franklin is the substring that all of this simplifies to. Franklin, without a space. This substring simplifies to everything from the R in Roosevelt on. So the answer to this is Franklin Roosevelt, the capital F, and no embedded space. Because we did not carefully substring that's either one of those spaces into our pieces there, Java does not add that. Please put double quotes around your final answer. And number 12, blank 1. Blank 1 is wherever we find the first space. The first space in name 1 is this one right here, and that's position 0, 1, 2, 3, 4, 5, 6, 7, 8. We should have known that from the previous problem. So the variable blank 1, if you were keeping track of it in your scratch paper, the integer variable blank 1 is simply the number 8. The variable blank 2 is equal to, well, let's work from inside the parentheses out. 8 plus 1 is 9. Substring 9 of name 1 would be everything from Delano on, so Delano Roosevelt. And that substring, we're doing an index of a space on it. Well, that means we're hopping over this space. This space isn't even part of the substring that we're looking for. So this is very shrewd programming. This space is being found right here. But because this substring is now a separate substring, that space is in position 0, 1, 2, 3, 4, 5, 6. Because we're starting the D is sort of like position 0 of the substring, that space is in position 6. So blank 2, the variable blank 2, is currently storing the value 6. Now let's interpret this next line of code, working from inside the parentheses out. Blank 1, which is 8. 8 plus 1 is 9. Blank 1 here is 8. 8 plus 1 is 9. But this 9 plus blank 2 is 6. So 8 plus 1 plus 6. That adds up to 15. So I'm left with 9, 15. And what am I doing? Oh, name 1 dot substring 9, 15. So let's go to name 1 and let's count into the position 9. I think position 9, if you can tell through my my mess, position 9 of name 1 is the D. Position 15, if you count carefully, is this space. So we're starting at the D and we're going up to, but not including, position 15. So it's perfectly pulling out Delano. And that Delano substring is being stored into name 1. So all of this is overwritten. Name 1 is overwritten with just Delano. And when we run the system out print, we're purposely taking a star, an asterisk, and we're concatenating it to the new Delano. And then we're concatenating another star. There are no spaces embedded here, and the whole thing should be surrounded in double quotes as your final answer.